All right, welcome to your weekly Toolbox Talk. Now, let's get right to it. Fall protection is still the #1 OSHA violation, year after year. But here's the kicker. The fatalities we're seeing aren't from a lack of gear. They're from using that gear incorrectly. We're going to break down exactly why. Just let that sink in for a second. We're not talking about a snapped lanyard or failed anchor. We're talking about a small 2-inch adjustment, a seemingly minor detail with absolutely lethal consequences. So the conversation we have to have now isn't about having the gear. It's about using it with surgical precision. Before we really dive into the standard, make sure you're subscribed. You don't want to miss these critical updates we send out every single week.
Okay, so we're going to cover 3 major system failures. Think of them as the fit, the physics, and the foundation. These are the 3 mistakes that can turn a personal fall arrest system, your PFAS, into a deadly liability.
The first fatal mistake, it's all about the harness fit. And as you can see here, every single strap has a catastrophic failure mode. Let's look at that dorsal D-ring. If it's even slightly off-center, a fall will concentrate all that force directly onto the spine. The chest strap? Too high and you've got a strangulation hazard. Too low and you risk tumbling right out of the harness head first. And the leg straps? Oh man, the leg straps. Too loose and the impact could literally sever the femoral artery. And with the 2026 enforcement of 29 CFR 1926.95C coming up, getting this proper fit is no longer just best practice. It's a legal requirement. Now for mistake number 2, completely miscalculating fall clearance. It all starts with understanding this term, free fall. Simply put, this is the distance you plummet before your gear even starts to work. It's totally uncontrolled, and OSHA is crystal clear about this. It cannot, under any circumstances, be more than 6 feet. Okay, so after that free fall ends, your shock absorber, your deceleration device, deploys. The distance that thing stretches out to bring you to a safe stop is the deceleration distance. OSHA caps this at 3.5 feet. So remember those 2 numbers, 6 feet and 3.5 feet, because they are non-negotiable. They are critical parts of the calculation we're about to do. So here's where the rubber meets the road. You take your lanyard length, you add that 3.5 feet of deceleration, you add the worker's height up to their D-ring, and then, and you can't forget this, you add a 3-foot safety factor. That's for harness stretch and body settling. If you get this math wrong by even a few inches, your worker is going to hit the level below, period, even with a perfectly good PFAS. And this brings us to the third and final fatal mistake, a bad anchorage. Your top-of-the-line harness and lanyard are completely useless if what you've hooked into fails. So burn this number into your brain, 5,000 pounds. Per OSHA and ANSI, your non-certified anchor point has got to support a static load of 5,000 pounds per worker. You know what that is? That's the weight of a small truck. There are absolutely no exceptions. Okay, now let's pivot from the technical standards to human physiology. Because, arresting the fall is really only the beginning of the emergency. This is where we see the deadly results of not having a rescue plan ready to go. Brian's fall arrest system worked perfectly. It stopped his fall, just like it was designed to. But as he was hanging there, suspended in midair, a new clock started ticking. And this clock measures the time until his own life-saving equipment becomes a fetal threat. This is what's known as suspension trauma. And it's a nasty piece of business. While a worker just hangs there, motionless, gravity starts pulling blood down into their legs. The harness's leg straps then act like tourniquets, trapping all that deoxygenated blood and essentially starving the brain and vital organs. It can knock someone out and even kill them in just a few minutes. Survival comes down to following this protocol to the letter. A prompt rescue needs to happen in about 4 to 6 minutes. But what you do after you get them down is just as critical. Now listen, if you lay a victim flat, all that toxic deoxygenated blood that pooled in their legs can rush back to the heart all at once, and that can trigger cardiac arrest. They call it reflow syndrome or rescue death. It's absolutely vital that the victim is kept in a seated or W position to prevent it. So what's the magic number? Well, research has established a 9-minute rescue plan. To make sure that no more than 5% of workers even begin to show symptoms of suspension trauma, that rescue has got to be complete within 9 minutes. So I'll ask you, does your site's rescue plan meet that standard? Have you drilled it? Okay, we've covered the failures. Now let's talk about getting proactive. Let's talk about control. What follows is an actionable checklist you can take with you and use to audit every personal fall arrest system on your site today. First thing, start with the webbing. You're looking for any fraying, any fuzziness, or pulled fibers. Use what's called the bend test. Just form an inverted U with the strap. That little move will expose any hidden cuts or damage. See any hard or shiny spots? That's heat or UV damage, and the fibers are shot. Any of this stuff means you pull it from surface immediately. Next, you need to check every single stitch. Pay special attention to the area around the D-ring pad. That's a huge load-bearing point. If you see any broken, missing, or pulled stitches, its integrity is gone. Under the force of a fall, that is exactly where a catastrophic failure is going to happen. Now, let's inspect all the hardware. I'm talking D-rings, buckles, adjusters, the whole shebang. Any orange rust or signs of corrosion is a major red flag. Look really closely for pitting on the metal surfaces. Those tiny little indentations create stress points that can snap clean off under load. And of course, check for any bending, distortion, or sharp edges. And finally, check the labels and indicators. If you can't read the manufacturer's tags, you have no idea how old it is or what standard it meets. Take it out of service. If any of the fall impact indicators have been deployed, it means that harness has already done its job once. And I need to be absolutely clear about this. A harness is a single-use device. After it has arrested a fall, its service life is over. Done. Destroy it. So you've done your audit, your gear is in perfect condition. That's great. But I'm going to leave you with this one question. Is your rescue plan practiced? Is it on site? And is it fast enough to beat that 9-minute physiological clock? Because the best gear in the entire world doesn't mean a thing if you can't get your team member down in time.
And that's your breakdown. Make sure you subscribe for next week's deep dive into electrical safety. And please, use what you've learned today. Stay vigilant and stay safe out there.